Hi everyone, good morning, and welcome to our live stream. This will be short as I'm just going to discuss to you some important points before we wrap up the semester. And I hope that your classmates are also here. Parang biglang kumonti kayo. Okay, let's just wait for the others before we can start. Okay, I think we'll be wasting time if we will wait for your other classmates. I think there are 20 students supposedly, but only 7 are in attendance today. So just inform them of this video later so they can watch it offline, or you can tell them so they can still catch up with us. So the reason why I asked you to join me for this lecture is I'm going to discuss to you some other tests which we were not able to perform, usually non-parametric tests and other types of tests. So let's start with let's see, ANOVA. Okay, a testing hypothesis about 3 or more independent groups. I hope you opened your SPSS so you can join me. I'd like you guys to um, open now your SPSS so we can proceed immediately later. For one-way ANOVA, just to give you a recap, this is a test that makes use of the means of the independent groups. Okay, so in other words, it uses both means and standard deviations. So for ANOVA, we are going to compare three independent groups. Okay, if there's a difference between the three groups using means and standard deviation, and this one is similar to your t-test for independent samples, where in t-test we are comparing two independent samples if these two independent samples actually differ or not. However, if there's more than two, then we can go for ANOVA. But can we use ANOVA if there are only two independent samples? The answer is yes for your SPSS. So, pwede natin gamitin ang ANOVA kahit two independent samples lang using your SPSS. But of course, there's a test that is designed for that, and that is your t-test. But like what is written here, we know that ANOVA is just an extension of your t-test for independent samples. So we have here the alternatives for non-parametric tests, meaning if the assumptions, there are three assumptions in one-way ANOVA are not met, or if one of them is not met, then we can make use of the alternatives like your Kruskal-Wallis test, Chunkier-Tapster test, or the Nijan test. Now, there's one thing also that I'd like you guys to know about ANOVA, specifically your post hoc test. Now, what's post hoc test? We can perform the post hoc test if we would like to find out, let's say there are three independent samples where the differences lie. So for example, the post hoc test is useful if we were able to determine a significant difference between the three or more independent samples, for example. But the question is, where does the difference lie? Ayun, where does the difference lie? So let's say sample A, B, C, and D, and then we performed ANOVA, and we found out that there is a significant difference. But the question is, by just performing analysis of variance, one-way ANOVA, we do not know where the differences or the difference lies or lie or lies. Okay, so is it between A and B, or is it between A and C, or is it between A and D, o baka naman between B and C, or B and D, or C and D? So those are the possibilities, but we cannot tell that if we only perform one-way ANOVA or analysis of variance. So what will determine that is your post hoc test. We're going to perform a post hoc analysis. Okay, so that's the importance of the post hoc analysis. Okay, so we are going to compare all the groups and find out which among the groups differ. Okay? Alin sa kanila yung merong pagkakaiba. And that's what we are going to do and perform ngayon. So, I'd like you guys to open your SPSS and load again the data which we use and yung birth weight, that SAV. Kindly open the data birth weight that dot SAV, and we're going to perform ANOVA and post hoc analysis. We did the ANOVA already before, if you remember, but we were not able to perform the post hoc analysis. And that's what we are going to do today. Okay, so go ahead and open ANOVA and then load birth weight.sub. That's from the file which I gave you before, and the same file that we've been using. Okay. So just let me know if you were able to load the file already so we can proceed with our testing. Okay, so you're done. Then next thing that we are going to do is, wait, I'm just going to show you my screen. So just like what we did, we are testing the null hypothesis. Ano ba yung problem natin dito? Let's check out. Ayan. Do babies' birth weights differ across the mother's history of premature labor groups? So our hypothesis here is the baby's birth weights do not differ across the mother's history of premature labor groups. So we're going to test the same hypothesis. Okay, let's just share the other screen. All right, so here we go. Let's perform analysis of variance and at the same time, our post hoc analysis. So premature, saan na yun? History of premature labor. So yan yung ilalagay natin. And then, okay. So dependent this would be birth weight. So ang tinitingnan kasi natin kung may pagkakaiba ba sa birth weight ng mga babies for mothers with history of premature labor. So our dependent variable here would be your birth weight, baby's birth weight, and then the factor would be history of premature labor. And then you click post hoc analysis, this one, and we're going to use Sheffy for our post hoc analysis to determine which among the groups we already performed this analysis before, and we already found out that there is a significant difference. But what we are doing here now is we are performing the same test because we would like to find out where the difference lie or differences lie. Okay, so tick the box, Sheffy, then continue, then okay. So this will be the output. So we have here ANOVA box here, and we have the p-value, which is 0.00. That's why we know that there is a significant difference in the birth weight of the babies based from the history of premature labor of their moms. But what we are interested in is this one, the multiple comparison table for post hoc analysis. So how do we interpret this? So for here, we can see that the p-value of those who do not have any premature labor history and those who have experienced premature labor once, ito, none versus 1, we see that the p-value is 0.00, and then this is less than 0.05. So we know that those who do not have a history of premature labor and those who once experienced premature labor differ. They differ in the birth weights of their babies. So that's where the difference lie. Yung none and 1. None and 2 do not have any difference because the p-value here is 0.889 and this is greater than 0.05. So there's no significant difference. Okay. So 1 and none is the same as none and 1. 1 and 2 is no, yeah. 1 and 2, wala din. 0.193, 2 and none, pareho yan. Hindi ba? Yan. None, 2, 2, none is the same. 2, 1, 1, 2 is also the same. So, by performing the post hoc analysis, by performing the ANOVA first, we know that there is a significant difference. And then, by clicking the post hoc analysis for Sheffy, we know that the difference lie between none and 1. Yung walang history ng premature labor at yung merong isang beses na history ng premature labor. So doon yung pagkaiba. Okay, so nakita natin na hindi lahat ng multiple comparisons ay may pagkakaiba. Pero ang pagkakaiba ay yung sa dalawang pairing na none and 1. So that's where the difference lie as evidenced by the p-value which is equivalent to 0.00. Okay? How did you know? Sa Irene, baka late kang pumasok, Irene, kaya hindi mo na catch up. But how about for the rest? Ano? So that's how you guys perform. Let's do another example. Okay, let's perform ANOVA using the same data. Siguro birth weight for those who, let's check. The smoking status siguro. And smoking status during pregnancy. Kung nag-smoke ba sila, ganyan. Okay? Let me just check kung ano to. We only have 2 categories here, ano? Wag yan. Let's look for another variable using the same set of data. How about the age of mothers in year? Or mother's weight? Sige, mother's weight tayo. Kindly choose mother's weight. So, kumbaga dito, titignan natin kung yung weight ba ng mother will affect the weight of the baby. Okay. I don't know if we can perform post hoc analysis here because the first thing we need to know if there is a difference. So, ANOVA muna. But i-check na rin natin. I-check nyo na rin yung Sheffy. Para just in case may difference, hindi na tayo magre-recalculate. Okay. So, check post hoc analysis, then Sheffy, then continue. And then press OK. So, tignan natin muna yung ANOVA natin. Okay, so in this example, where we compared the birth weight of the baby and the weight of the mother, titignan natin kung may pagkakaiba ba. So, kung ano ang diferensya. Dito, mayroong pagkakaiba. Saan na yun? Oops. Okay. So, we cannot perform, sabi dito, post-hoc tests are not performed for birth weight because there are more than 50 groups. Masyadong marami yung groups pala. But there is a difference, ano? Hindi natin nakita. Okay, so failed example. Tingnan natin yung iba na kokonti lang. Yan, yes or no lang naman kasi yan. What is this? FTV. Ito, I just do not know what FTV is. So, try natin yung FTV. Ano yung FTV na yan? Number of physician visits during first trimester. Ayan. Kung ilang beses sila bumisita sa kanila physician, yun yung FTV. So, try natin yun. So, it's one way ANOVA. Our dependent list would still be birth weight. So, this time, ang gagamitin natin ay FTV. Ito, number of physician visits during first trimester or FTV. Yan ilalagay natin sa factor. Yung mas maraming beses ba bumisita sa kanilang OB or sa kanilang physician, mas mataas ba yung birth weight ng kanilang mga babies. Okay, so yun ang ating hypothesis that there is no significant difference in the birth weight of the babies as per the number of physician visits during the first trimester of the mother. So post-hoc analysis again, click that and then make sure that the Sheffy box is ticked. Then click continue. I hope you guys are doing this also. So click continue and then okay. Basically, it's the same step. Let's just take a look at the results. Ayan. So first, tignan natin yung one-way ANOVA. So, kung may diferensya, kung may significant difference, or if the p-value is less than 0.05, then may post-hoc analysis na magaganap. So dito, lumalabas that the p-value is 0.005. So therefore, we reject the null hypothesis, which means that there is a significant difference because this 0.005 is less than 0.05. Okay? So tignan ngayon natin dito kung nasaan yung difference. Ayan. Meron ba tayo? Bakit lumalabas? So, yun. P-value. 1, 2, 3. Bakit parang may mali dito sa data natin? Okay, I think something is wrong, but the closest is 0.06, but this is still greater than 0.05. But according to birth weight, so meron siyang missing analysis, ano? Ayan, so may mali dito sa ating data. Yeah. Okay. Wala tayong mahanap dyan. But anyway, that's basically the idea, guys. So, ganun yung pagkuha natin. Ito kaya, I-raise naman kasi ito. ETL is dalawa din lang. 01. FTV has... At kaya yung 1, 2, 3, 4. Okay, anyway. So, basically, just like what I said, ganun yung gagawin natin, ano? Kasi dito, 1, none, 1, 2, 3 lang sa FTV natin. Pero yung lumabas doon sa post-hoc analysis, may 4, may 6 pa, ano? So, maybe may mali doon sa entry natin sa data. So, yeah. Ganun lang yung kailangan na gawin, guys. I-click nyo lang yung post-hoc analysis, and then the comparison would be on the p-value, just like dun sa unang example natin. Okay? Dito. So, this is a very good example. Yan. So, yun ang gagawin natin for post-hoc analysis. Lalo na pag kayo ay meron later research, kasi I think teachers from DepEd are encouraged to conduct a research na kapag ganito at may mga comparisons kayo ng independent groups na gagawin, then you can perform the post-hoc analysis to identify kung nasaan yung pagkakaiba. Okay? So that's very important to know where the differences lie. Okay? So were you able to follow? So that's for post-hoc analysis. Nasundan nyo ba, guys? Mga mom sensors. Nasundan po ba natin? Ayan, yes daw. Sabi ni Aiza, tsaka ni Harvey. So, yun. Let's proceed to the next na i-explain natin. So, I think we were able to perform Kruskal-Wallis or not. Hindi pa. Okay? So, let's try Kruskal-Wallis this time, tests. According here, Kruskal-Wallis test is the alternative to one-way ANOVA. So we use to test if independent populations have the same center. So it means it uses medians of ranked data instead of mean and standard deviation. So for example, ang given na data ninyo ay rank data, okay, ay hindi natin pwedeng gamitin ang mean or standard deviation dahil nga rank yung data natin. So, gagamitin natin dito ay yung median as a measure of central tendency. So, if that is the case, hindi natin pwedeng gamitin yung one-way ANOVA. We know that the populations are independent. Okay, that's check for ANOVA. Pero ang given kasi ay rank data. Yun. So, hindi natin pwedeng gamitan ngayon ng mean and ng one-way ANOVA, kasi ang one-way ANOVA ay gumagamit siya ng mean and standard deviation, whereas if the data given is rank, ang gagamitin syempre na pinaka appropriate is yung median. Okay? So this, guys, is an extension of the Wilcoxon test. Okay? So the data is set up in the same manner as the Wilcoxon test and Mann-Whitney tests, making use of ranks, all of them, but there are more than 2 independent groups to be tested. So for Kruskal-Wallis, there are more than 2 independent groups to be tested. Okay? Katulad nung t-test, pag 2 groups lang, tapos pag 3 groups and more, o 2 or more groups ay sa ANOVA naman tayo. So dito naman, pag 2 groups, gagamitan natin ng Wilcoxon at saka Mann-Whitney tests. Pero kung more than 2 independent groups na yung given, ang gagamitin naman natin ay Kruskal-Wallis test. So this is a non-parametric test, meaning regardless if the population is normally distributed or not, wala siyang paki doon. Kapag mayroong mga outliers yun, pwedeng gamitin itong Wilcoxon test. At syempre kapag ang given ay rank data. So, ang example natin dito ay itong effect of supermarket shelf. Okay? Pakitry nyo ngang hanapin yung ating data for, tignan natin. Oops. Yung ice cream data. Okay, kindly check yung ating ice cream data. Ice cream.sav. Pakiload po yung ice cream.sav. Meron ba dito? Ayun, ice cream.sav. Yun ang i-load ninyo. Okay, wait lang. Paki-load yung ice cream.sav. So, ito yon. Meron yung first column natin ay days, levels, and sales. Days, levels, and sales. Ayan. So, dito sa ating ice cream data, ang ating, anong tawag dito, titignan ay kung magkakaiba ba yung sales ng mga ice cream na na-arrange, ayan, sa level, ayan, ng, paano kaya? Ng shelf na parang freezer, ano? Pero may 3 levels siya. Yung isa ay knee level, yung isa ay waist level, yung isa ay eye level. Okay? Yung level which is labeled 1, 2, 3 ay yan yung ibig sabihin ng 1, 2, 3 na yan. Okay? For levels, so what are the levels? Knee level, waist level, and eye level. Kumbaga, kung pumupunta ka sa groceries, sa supermarket, at bibili ka ng ice cream, at may malaking fridge doon, freezer, tapos yung may 3 shelves siya, levels, yung knee, waist, and eye level, where would you most likely to buy your ice cream na level? Kasi minsan, di ba, lalo na pag yung nasa baba, at masakit yung likod mo, parang ayaw mong silipin. So, kung ano yung nandun sa, maybe lang sa eye level, pag ako bumibili, mas madali ko makita yung mga nasa eye level and most likely dun ako bumibili. So dito, titignan natin kung may ganun bang effect? May pagkakaiba ba ng sales? Depende doon sa kanilang leveling. So makikita niyo yung leveling is actually ranking. Kasi merong mas mababa, merong mas mataas. So yung data natin ay rank. So titignan natin kung may differences ba yung sales. So since rank ang ginagamit dito, hindi natin pwedeng, so immediately you can say na, ANOVA ang gagamitin dito. Kasi differences of the three groups na independence. No. Titignan mo kasi rank yung gagamitin na data. Ano? So, it's rank. So, hindi natin siya pwedeng gamitin. So, ano ngayon ang pwede nating gamitin? Itong non-parametric test. So, paki-check, pakipunta yung cursor nyo sa non-parametric test. So, analyze, non-parametric test, and then independent samples. Okay? Independent samples. Just let me know, guys, if you can follow. Ano? So, independent samples, click independent samples. Ano kaya to? Identify difference with two. Ano nangyari dito? Fields. Ayun. Nasa fields pala tayo. Dapat. Okay, so ano ang gagawin natin? Ilalagay natin yung test fields dito. So sales, ang ilalagay natin sa taas sa test fields. And then for groups, we have the shelf height. Ayan. Shelf height. So, ang pipiliin natin dito, okay. So, punta kayo sa fields. Sa pagkatapos nyo dyan, punta kayo sa settings. When you go to settings, makikita nyo dito yung choose test, test options after missing values. So, click choose test and then tick Kruskal-Wallis test. Ayun, Kruskal-Wallis test. Can you guys follow? Okay, inuulit ko. Click settings. After nung mailagay nyo dun sa mga boxes, settings, choose test, then customize test, then click Kruskal-Wallis. And then run. Run. We run the test. Hindi tatakbo tayo. Run the test. Okay. Here we go. Anong nangyari? Ayun. So may lalabas dito na hypothesis test summary. Our null hypothesis is, ang galing ha, the distribution of sales is the same across categories of shelf height. Okay, ibig sabihin, medyo halos pare-pareho yung ating null hypothesis daw yung sales. Ngayon, ang test na ginamit natin is independent samples Kruskal-Wallis test. And the p-value is 0.001. The decision is already here. Reject the null hypothesis. So meaning, there is a difference in the sales according to the levels. So may difference siya yung sales according to the levels. So, walang masyadong binigay dito na data, no? Lalong-lalo na yung sa median. Basta ang sinabi lang dito is there is a difference. Now, let's try to perform pairwise analysis. Tingnan lang natin, ano? Meron ba dito? Median test. So, yan. I'm just going to rerun this. Ayan. So, even the medians are not the same, ano? So, sinasabi dito that the medians of sales are the same across categories of the shelf. But according to the test, the median test, 0.00 pa rin ang ating p-value where we reject the null hypothesis. Meaning, the medians of sales are different. The medians of sales differ across the categories of shelf height. Yan. Okay, nagets ba ninyo? Ulitin natin. Eh. So dito tayo. Try natin dito sa legacy dialogues. Non-parametric test, legacy dialogues, para makita natin, ano? K independent samples. Okay, try natin. Oh, iba naman to, ano? So test variable would be shelf height. No. Sales. And then shelf height would be the groupings. So i-define natin, minimum is 1, maximum is 3 kasi yun ang ating ginamit. So naka-check na yung Kruskal-Wallis. So you can check median also if you want. Ayan. Then you can click OK. Ano kaya nandito? Tignan natin. Descriptives lang. Okay. So that's about it. So this is a different way, of performing the Kruskal-Wallis. Pupunta lang kayo sa Analyze, Non-Parametric Test, then Legacy Dialogues, and then K-Independent Samples, and then pupunta kayo dito. So the test variable would be sales, and then the grouping would be yung ating shelf, okay? So if you will define the range, the minimum is 1, the maximum is 3 kasi 3 levels siya. Okay, then press OK. Mas maraming information ang lalabas dito. Yan. So for the Kruskal-Wallis test, so meron tayong mean rank. Then we also have the chi-square test to test yung kung meron bang relationship yung sales doon sa shelf level. Okay, so lumalabas dito na meron 0.001, so meron. Sa test statistic natin, ito. So, ang ating p-value is still 0.00. So, meron pa rin. There is a significant difference in the sales. Now, if you look at the median, lalabas na ang median natin dito ay, saan ba yung median? Ayan. Median is 86.00. Yan. So, ibig sabihin niyan yung median sales natin. Okay, and then the mean rank is 19. Yun. So, based from the min rank, lumalabas na there are more sales na mas maraming nabibenta na ice cream pag nasa waste level nakalagay yung ating ice cream. Okay, ito yung ibig sabihin ng min rank na ito. So there are more sales when the ice cream is placed on the waste level. Okay? Mas kokonti ang sales sa knee level. So siguro nga dahil nga pag bibili tayo, ay ayaw natin yung yumuyuko pa tayo, lalo na pag medyo tumatanda na, kagaya namin, ayaw na natin na yumuyuko pa tayo para may bilhin doon sa baba ng shelf. So usually, yung kayang abutin ng kamay natin, so sa waist, ang pinakamarami, sumusunod naman ang nasa eye level. Okay? Nasa eye level naman. Okay, so that's how we perform Kruskal-Wallis test and how we interpret the data, yung computation na lumalabas from the data. So you can use min ranks to determine kung alin yung maraming sales. And then of course, yung nating test statistic, which is the p-value of 0.005, so meaning there is a significant difference, difference in sales of the different shelves level. Okay? So, yun yung ibig sabihin nito. Again, the chi-square statistic will tell us the relationship, nitong dalawang variables natin na independent at tumalabas na meron nga silang significant relationship. So in other words, the sales is affected by the level on where the ice creams are stored or placed. Okay? So, yun. May tanong po ba? Nakuha ba ninyo, guys? Yung ating Kruskal-Wallis? It's the non-parametric counterpart of the analysis of variance. So, we make use of this kapag ang ginamit ay rank data. At also, pwede rin itong gamitin kapag alam natin na yung ating population distribution is not normal. Okay, do you have questions then? Meron po ba kayong tanong? Or can you guys follow? Yan, sabi ni Hazel, yes daw, nakaka-follow daw. So si Hazel lang ba, tsaka si Flory, yung naka-follow dun sa ginawa natin. Dalawang ways, yung pinakita ko sa inyo on how you are going to test null hypothesis na involving itong Kruskal-Wallis test, which is a non-parametric test. So, wala daw. So, ibig sabihin, this part is clear. Ayan, nakaka-follow. And now, there is an additional information which I'm going to give you. Sino sa inyo dito yung nasa teaching profession now? Yung nagtuturo na mismo, na nasa DepEd? Tignan ko nga kung meron sa inyo. May I know, guys, kung sino sa inyo yung nagtuturo at nasa DepEd, yung employed? So I would know if I will discuss an additional topic. Na alam kong makakatulong sa inyo. Walang nagtuturo. Presently employed. Ayos yung nga no? Sa DepEd sana, sa Irene pala. Ma'am Irene pala is, co-faculty natin, na nasa system din. Si Noveline pala. Nagtuturo siya. At saka si Hazel. The reason why I'm asking you guys if you are currently employed, is may mga natatanggap kasi akong trabaho or anong tawag dito? May mga humihingi ng tulong ko as a statistician on their studies sa DepEd. I think some of them are doing some action research. And most of the time, ay pinapahanap sa kanila yung effect size. So, ang napansin ko sa DepEd, mostly ng research design nila ay yung pre-test, post-test design. Or sometimes before and after design. Ayun. So, yun yung nakikita ko palagi. And most of the time, there are only two groups. So, pag ang ating before and after kasi, before and after yung research design mo, ang gagamitin natin dyan to determine kung may significant increase ba doon sa performance ng estudyante after ng experiment mo, di ba, ang ginagawa sa DepEd. Just let me know, Noveline and Hazel, kung meron kayong kakilala din na nagre-research ngayon. Before and after kasing ginagawa nila. So, ibig sabihin, may nakita nilang, since action research ito, may nakita silang problema sa classroom nila. So may naisip silang intervention. Te-testing nila ngayon tong intervention na ito kung effective ba sa pag-increase ng performance ng kanilang mga estudyante. I understand na ngayong pandemic, marami sa inyo ang gumawa ng mga YouTube channels, and then a lot of you are creating video packages para sa inyong mga lesson. Okay? As an intervention, kung sa pagtuturo ninyo sa mga estudyante ninyo, lalong-lalo na ngayon, at iba yung ating situation. So may isa sa akin na nagpagawa niyan. So meron siyang ginawang video na nasa YouTube at ito yung tinesting niya kung effective ba ito na intervention. Kung mag-i-increase ba yung performance ng mga estudyante niya sa mathematics. So ang ginawa niya ay wala siyang controlled at saka experimental group, single group lang ginawa niya. Nagpa-pretest muna siya and then yun, ginamit niya nga yung intervention niya and then nagkaroon siya ng post-test. So yung design niya ay pre-test, post-test design na isang grupo lang. Ayun. Ngayon, may problem siya doon na what is the effect size daw ng differences ng pre-test and post-test. Ang gagamitin nyo kapag ganun, ang inyong research design ay itong tinatawag natin na Cohen's T. Ang nakita ko sa kanila, even pre-test, post-test, before and after yung design nila, gumamit sila ng eta squared. And I don't know, maybe if there are experts who are watching this, but as far as I know and as far as what I have learned, kapag pre-test, post-test, before, after, ang design mo, ang gagamitin mo dapat ay Cohen's T for the effect size instead of the eta squared. Kasi ang eta squared usually is being used for analysis of variance, ANOVA. And we know that ANOVA tests the differences between independent variables. Ang t-test for Cohen's T, ang tinetesting nito ay kung paired samples siya. Ayan, paired yung samples. So paired siya kasi before and after, ano pa bang tawag dito? Pre-test, post-test yung design, kaya paired. So kung paired yung samples mo, hindi ka pwedeng gumamit ng test for effect size which tests independent samples. So mali na yung nagamit doon. So ito lang yung gusto kong i-discuss sa inyo na pwede nyo gamitin itong t-test effect size using Cohen's D. Kung gusto yung malaman yung effect size nung pre-test and post-test scores ninyo. Okay, pag sakaling kayo ay mag-action research diyan sa DepEd. Alam nyo, napakadali ng action research. Ang mahirap lang is the implementation of the intervention. Dapat titignan mo ng mabuti para yung mga ibang factors that may affect the result ay hindi masyadong malaki yung impact doon sa research ninyo. So marami sa inyo dyan na if you are presently employed sa DepEd, baka gusto nyo mag-research na akala nyo napakahirap, madali. Ang kailangan nyo lang ay mag-isip kayo ng intervention doon sa problemang nakita nyo sa klase ninyo. There's an existing problem sa classroom. Think of an intervention which you believe will solve that problem. And then that will be your action research. Okay? At gagamitan nyo yan ng t-test for paired samples. Is there a significant difference in the pre-test and post-test of the students? Okay? Now, if there is, what then is the effect size? Yun usually yung kanilang research problem. So if that is your research problem, we are going to make use of the Cohen's D. Test for effect size para sa t-test. So this usually, how they perform the Cohen's T, the mean of the pre-test minus the mean of the post-test, or baliktad, mean of the pre-test, post-test minus the mean of the pre-test divided by the standard deviation. Okay? Or, sige, papakita ko lang, what does the D interpretation of the D mean? Okay? May lalabas kasi yan na Cohen's D ito, Pag ang D is 0.2, small yung effect. Pag 0.5 ay moderate yung effect. Effect ito ng intervention. Pag 0.8 yung lumalabas, large yung effect. Okay? Now, I'm not going to show you kung paano mag-compute niyan using SPSS. Kasi ang SPSS, ang kino-compute niya lang ay yung eta squared for ANOVA. Okay? Pero napakadali lang nito, meron tayong papakita ko lang sa inyo na you can compute for Cohen's d using the internet lang. Yun lang yung gusto kong maipakita, no? So, i-stop natin yan and then we share para hindi kayo gagastos just in case kayo ay magaganito. Na-study sa DepEd. Kasi sa akin may mga pumupunta, no? So, syempre sisingilin ko sila. But of course, since you are my students, I'm just telling you guys na pag may ganun kayong study later on, and the design is pre-test and post-test, then you can just go to the internet and calculate. Ito. Ano? Kung nasaan na yun? Share. So this is the site na pwede niyong puntahan. Yan. So this is it. Ito yung pwede niyong puntahan. At meron siyang effect size calculator for Cohen's d. Pero pipiliin nyo lang kung alin yung gagamitin ninyo. So for example, ito, calculate DNR using means and standard deviation. So yan. Ito ay separate groups ttest. Ito naman ay means and standard deviations of two group, treatment and controlled. So kung meron kang treatment and meron kang controlled, ito yung gagamitin mo. Okay. Ito naman ay separate groups t-test. Okay. So pwedeng itong gagamitin. Diyan lang, sa effect size. So, yun lang. Additional information lang. Pwede kayong mag-calculate. You don't need a statistician, para calculate yung effect size. Since tinuro ko naman sa inyo ang paggawa ng t-test for dependent sample, for paired samples, so you can perform it on your own. So you don't need ayun. Sorry guys, hindi ko pala na-add yung Okay, so ang sinasabi ko lang offline ay yun, that's just the information that I would like to share for that topic, yung effect size for paired samples t-test para sa mga nagbabalak later na mag-conduct ng kanilang action research na merong ganong klase ng design. Yung pre-test, post-test, pwede rin yung controlled and experimental group, ganun, pwede rin siya. Pag gusto nyo later. So that you don't need to hire a statistician to do it for you kasi tinuro ko naman yung t-test for paired samples. And then, to compute for the effect size, you can just go to the internet, yung nakita nyo kanina na site na pinapakita ko. You can just go there at i-enter nyo lang yung mga data na kailangan, like means, ganun. Pwede nyo naman kunin ang means, standard deviation sa SPSS. Punta lang kayo doon sa descriptives. Tinuro ko na rin yan dati sa inyo. So, you can be the statistician of your own study para hindi nyo kailangan mag-hire. Kasi yung mga nag-hire sa akin, like they pay around 2,000 for that testing, Hindi siya madali kasi lalo yung mga nagbibigay sa akin ng data ang gulo-gulo. So, inuubos ko yung oras ko na pag-aayos ng kanilang mga data. But for you, since nag-under kayo sa klase natin, you can do that on your own. So, may tanong po ba? So, this is an additional topic, parang enrichment, extension na lang siguro na topic natin. So, do you guys have questions? May katanungan po ba kayo? Kasi kung wala, this will be, we're going to end our live discussion now and just prepare for the final examination. So, meaning we're done with the semester. We'll just have the final exams. Kindly inform those who are not attending the class to please watch the videos kasi if they will not be able to pass the exams, then I have no choice, guys. You know what that means already. Ayan. So, kung hindi kayo nag-a-attend ng klase, ibig sabihin, hindi rin magigets yung mga ginagawa unless you're going to, of course, watch the live replay, the replays. Okay? So, mayroon ba kayong tanong? Irene, I will announce kung kailan, but definitely next week, Next week na yung ating final examination. Okay, ayun. I hope nasagot ko yung tanong niyo, Lorraine and Irene, mga ma'am and sirs. So, mag-prepare lang kayo. I hope na-submit nyo na rin yung mga kailangan yung i-submit, Yung binigay ko na part ng inyong module. So, please submit those para kumpleto lahat. Alright, so I think that's it for today, guys. Thank you for joining me here and participating in our discussion. Yung mga wala, pakisabihan nyo sila na manood ng mga previous lives natin para alam nila yung gagawin nila. Okay, I will make announcements in our group chat. Okay, so I think that's it. Thank you so much for joining me. You can have your lunch now kasi it's 11:17. I know you have a lot of things to do. So thank you so much for your time, guys. Have a great Sunday. Goodbye.